Let's go over the parabola pre-assessment dealing with standard form. So this equation that we see here is in a form that we call standard form. And that standard form means that it's in this. Y equals ax squared plus bx plus c. That the coefficient of my x squared value, which would be my, let's choose a different color, my a is the number in front of the x squared. So in this example, the coefficient in front of x squared is 1. It's invisible because it's understood. The b value is going to be the coefficient of x, which is -4, and my c value is going to be the constant, which is -1. So when we start off each of these problems, we might want to write down these on the top just so we can refer to them as we move through the graphing of these things. So starting with that and understanding the format that the equation is in, as well as understanding what we're doing. So there's really some key points. Number one that we need to see on this graph. We need to see the axis of symmetry. And then the other key thing is we need to see 5 points and their coordinates. So I need to see 5 points and their coordinates, and a couple of those 5 points have to be specific that we all have. First one is everybody should have the vertex. Everybody should have the y-intercept. And then I don't care about the 3 additional points, but 2 of the 5 points definitely have to be the vertex and the y-intercept. And then how you get those other 3 points, either by mirroring or or plugging in and choosing in x, that's up to you. But we need 5 points. This graph needs to have the axis of symmetry. It needs to have 5 points, and of those 5 points, 2 of them have to be the vertex and the y-intercept. So we see that step 1 is the axis of symmetry. So let's figure out how we can find the axis of symmetry. We use this equation, x equals the opposite of b over 2a. So this is where it pays off for us writing those values down. So this negative is part of the equation. So I'm always going to write that negative. And then I also need to write what my b value is. And my b value is -4. So the negative in -4 is different from the negative in there. And somebody is looking to lose their privilege in having recess as they knock on my window while I record. That's not going to work out well for that student. And look at those crazy girls. And the little 5th or 4th graders. All right. So that being said, 2 times a is 1. So the opposite of -4 is +4. 2 times 2 is 2. And we get 4 divided by 2, which is 2. So my axis of symmetry is x equals 2. And this is a linear equation. We remember that when we see a single variable, it's either horizontal or vertical. This says x equals 2, so it's going to go through the x-axis at 2. So we're going to draw a dotted line because it's not part of the solution. This is just a it is a reflection point, and it helps us center the parabola. And the parabola will mirror, because it's symmetrical, so points will mirror based upon this axis of symmetry. So it's really a guiding post. It's a guiding line, image, to help us reflect it. And also, we know that the vertex lies on the axis of symmetry. So if we're going to find the vertex, the min or the max point, we know that it lies on the axis of symmetry. So the vertex is going to have an x value that is the same as the axis of symmetry. So I know that I'm going to plug 2 in for x into this equation and find out what my y value is. So I'm going to use the original equation, y equals x squared minus 4x minus 1, and we're going to plug in 2. So we're going to do 2 squared minus 4 times 2 minus 1. We're going to square 2, which is 4. We're going to multiply negative 4 times 2, which is negative 8. We're going to do 4 minus 8, which is negative 4. Minus 1 is negative 5. So when I plugged in 2, I got negative 5. So this is going to be my vertex. So I'm going to go to my graph. This is my first point, and it is 2, negative 5. So this is the bottom of my parabola, and I'm going to label it 2, negative 5. It needs to be legible. I need to be able to read it. It needs to be next to the point. And these are things that you definitely need to have on your assessment tomorrow. Step 3 is going to be y-intercept. Now the y-intercept is easy because the y-intercept, when it's in standard form, is going to be my c value or my constant. And my c value in this example is negative 1. So my y-intercept is going to be negative 1. So we're going to go here. We're going to find negative 1. We're going to make a point. 0, negative 1. Now the other thing that we should know, and something that's important, is all y-intercepts have an x value of 0. X will always equal 0. So the coordinate of my y-intercept is 0, negative 1. You see that the x value is 0. And if we had plugged 0 in for these two x's, that would have been 0, this would have been 0, and we would have been left with negative 1. That's why our constant is always our y-intercept, because any other variable in that equation is going to go to 0 and leaves me with my constant. Now we're going to reflect this point. We're going to reflect the y-intercept. That y-intercept is 2 away from the axis of symmetry. So if it's going to have the same shape, then we're going to reflect it over the axis of symmetry, and we're going to make it 2 away from on the other side. So that's where all of this gets fun, where we use the shape of a parabola is going to be symmetrical, so we know the distance away from the axis of symmetry will be uniform, consistent. If it's 2 away on the left, it's going to be 2 away on the right. Now that coordinate is not 2, its x value is 4. Its y value will stay the same. So now we go back to the origin in finding its location. 1, 2, 3, 4, and then down 1. Down 1. Okay? So make sure you understand how to write that location. So we have 3 points. We've done the axis of symmetry. We've plotted the vertex, we just plotted the y-intercept, and we just did one of the 3 points. One of them was the mirror of the y-intercept. So now I still have 2 more points. So I need to find a 4th point. Well, find a 4th point, I need to pick another x value. So what x values have I used at this point? 0, 2, and 4. So I need to pick an x value that I haven't used. And an easy one, we tend to want to pick an x value close to my vertex. My vertex's x value is 2, so I'm going to pick 1. Let's keep it simple. X equals 1. We're going to plug it back into this equation, the starting equation. what is it, plus 1? Minus 1. That's my starting equation. Let's plug 1 in and simplify. I'm going to square 1. 1 squared is 1. Negative 4 times 1 is negative 4. Minus 1. We get 1 minus 4 is negative 3 minus 1. Negative 3 minus 1 is negative 4. So when I plugged in 1, I got negative 4. That's my fourth point. 1, negative 4. 1, negative 4. That looks reasonable. That looks like a good location. Right? It works within the shape of the parabola that I was expecting to see. And if it's 1 away from the axis of symmetry, let's make it 1 away on the other side. And that location is 3, negative 4. I have 5 points, and I can now graph all of the solutions. That's why we draw the line. The line represents all of the solutions. That's what the question says. Sketch the graph. Sketch the graph. So we just sketched it. You need arrows at the end of your parabola to show that it goes on to infinity. I need to see the axis of symmetry. I need to see 5 points with 5 coordinates next to those points. And that's pretty good. That's question number 1. We're going to roll through these next 3. So the first thing I want to do is find my A, B, and C. My A is going to be the coefficient of x squared. This time it's a negative sign, so that represents negative 1. My B is the coefficient of x, which is 4. And my C is going to be the constant, which is negative 5. Let's find the axis of symmetry. Axis of symmetry, we use this equation. Opposite of my B value is 4. 2 times A, my A value is negative 1. I get negative 4 over negative 2, which simplifies to positive 2 again. So I draw, much like I did in problem 1. And once I find the axis of symmetry, I'm going to find my vertex by plugging in my axis of symmetry value. My equation's a little bit different this time. My equation this time is y equals the opposite of x squared plus 4x minus 5. So this is the first tricky part. So I have my negative, then I have my x value, and then I'm going to square it. Plus 4 times my x value minus 5. So I'm squaring. You notice that there are no parentheses including the x and the negative. So we need to understand that we are squaring x and then taking the opposite value. So we're going to square my x value, and then we're going to attach the negative. So if I do this properly, I'm going to square before multiplying. So 2 squared is 4, and then I have my negative. I have 4 plus 2, or 4 times 2, which is 8, minus 5. Negative 4 plus 8 is 4 minus 5. 4 minus 5 is negative 1. So when I plugged in a 2, I got a negative 1. And this is my vertex. 2, negative 1. 2, negative 1. That takes me right here. And this time I'm going to write this like that. I'm going to write it on top. Well, Mr. Mack, why'd you write your coordinate above? Here in the vertex in problem number 1, you wrote it below. Because here is something that is interesting that we have to be aware of. When my A value is negative, the shape of my parabola is going to be a little bit different. When my A value, when A is greater than 0, it's going to have a U shape. When A is less than 0 or negative, when A is positive, it's going to be U. When A is negative, it's going to be an upside down U. So in this case, my A was negative. So it's going to be a U, so I'm going to put that coordinate above because my shape's going to look something like this. Not like that exactly, but it's going to be something like that, so I didn't want my coordinate to get in the way. All right, I found the vertex. I can't mirror it because it's on the mirror. You see that it lies on the axis of symmetry. So the next step is to find the y-intercept. Y-intercept, two ways of doing it. You can either plug 0 in for x, or you know that it's your c value. Knowing it's your c value is much easier. My c is -5, so my y-intercept is going to equal -5. I go to my y-axis. Intercept means where it crosses the y-axis, and it's going to cross at -5. So I'm going to write that point 0, -5, and that is going to be 1, 2 spaces away. So I'm going to mirror it here. That location is 4 on the x. You see the 4 right there, 4 on the x, and it's going to be -5 on the y. I have 3 points. I need a 4th point. I've used 0, 2, and 4. I want a point that is close to the axis or to the vertex. So I'm going to pick 1. So I'm going to find my 4th point. 4th point by plugging in x equals 1. Here's my starting equation. The opposite of x squared, is it minus 4x? Plus 4x minus 5. Plus 4x minus 5. By plugging in 1, I have the opposite of 1 squared. Plus 4 times 1 minus 5. I'm going to square the 1 before I do the negative because there's no parentheses attaching the negative with the x. So that gives me -1. 4 times 1 is 4 minus 5. -1 and +4 makes 3 minus 5. And 3 minus 5 is a -2. So when I plugged in 1, I got -2. Plugged in 1, I got -2. That looks good. That looks like a good shape. That's 1 away, so I'm going to reflect it. That is the point 3, -2. And now we connect those dots. I do arrows on them. And I have 5 points. I have 5 coordinates. I have my vertex, which is 2, -1. I have my y-intercept, which is 0, -5. And then I have 3 additional points. We can connect them a little bit. There you go. All right, number 3. Ooh, remember, this is in this template. What do we notice here? We can see the x squared. There's an x squared, and I see the number in front of it. The number in front of it is going to be my a value, so I know that a is -1. My b is going to be the coefficient of x. But what do we notice? There is no x. There is no x value. So there's no x value because b is equal to 0. And now I'm going to do my c value, which is the constant, and my c value is -5. So just be aware that's where it's beneficial to be able to determine these things before you even start. Let's find, not the vertex, the axis of symmetry. And this is going to be some interesting things, a little bit different on the values we get. It's the opposite of b. Well, my b is 0. 2 times my a, which is -1, I get 0 over -2, which equals 0. So my axis of symmetry is x equals 0. This is where x equals 0. If we look at this, we move it, right? X equals 1, 2, 3, 4, -1, -2. So where is x equal to 0? Right on the y-axis. So let's find the vertex. We still find the vertex by plugging in that x equals 0 into the equation. My equation is fun, -x² minus 5, where x equals 0. So y equals the opposite of 0 squared minus 5. 0 squared is 0 minus 5 which gives me negative 5. So my point is 0, negative 5. 0, negative 5. Way down here. I notice that my A value, my A is negative, so I know my graph's going to go upside down. So why do I need to know that? Well, a little bit of where I place my coordinate. All right, now next step is y-intercept. Uh-oh! What do we notice? We notice that my y-intercept is already here. My vertex is my y-intercept. Bummer! My y-intercept in this case is also the vertex. The rook! Just kidding. Is the vertex. Too much chess. Y-intercept is also the vertex. So we can't use it as my second point. So here's the bummer of this problem. We have to find a second point. How do we find a second point? How do we find a point anytime? We have to pick an x value. So we've only used 0, so we're going to have to find a an x value that we haven't used yet. And you can do that. You don't need me, you can just start it. Cool. I'm doing a video. So I'm going to pick x equals 1. Using this equation again, the opposite of x squared minus 5, minus 1 squared minus 5. There's no parentheses because I'm going to square my x and then I'm going to do the negative. So my x value is 1, so I'm going to square that and then take the opposite value, which is negative 1. We get negative 1 minus 5, which is negative 6. So when I plugged in 1, I got negative 6. This is my second point. So negative 1, negative 6. Plugged in a 1, I got a negative 6. You know what the password is? No, not yet. Okay, well, just take your eyeballs and look at here. Oh, no, I can't do it that way. I was going to write it on there. That would have been bad. I will write it on a piece of paper. Sorry, multitasking. Good. Let me know if you run into any problems. Sorry. All right, we found our second point, which is 1, negative 6. Let's reflect it. So we reflect it, and that takes us to negative 1, negative 6. It's always fun when we reflect things over an axis, like the y-axis. We have 3 points. Let's pick a fourth point. So now we got to find a fourth point by picking another x. We've used negative 1, 0, and 1. So let's pick 2. We use the equation, negative x squared minus 5. We get the opposite of 2 squared minus 5. 2 squared is 4. The opposite of 4 is negative 4. Negative 4, negative 5 makes negative 9. So we get the point 2, negative 9. 2, negative 9 goes off the chart. So if you come to that point where your point is off, you picked an x value that throws you off, that's fine. Just get it in the relatively correct location, label it properly, and makes it a little bit harder to mirror it, but that can be done. The distance is still 2 away, so you need to go 2 away and just pick that correct coordinate. You have to label it. We're still going to draw, and we get that as our graph. Last one, sorry. Let's do that. Let's get rid of that page. Delete. Last one is problem number 4. We're going to go through the same things again. A equals 1, B equals 6, C equals 9. Since my A is positive, I know that it's going to be a U. we're going to still find the axis of symmetry first. My axis of symmetry utilizes this formula. The opposite of b over 2 times a, negative 6 over 2, which is negative 3. My axis of symmetry is negative 3. We make a dotted line representing that reflection, that line of reflection. We're going to find the vertex by plugging in that x value of the axis of symmetry. My equation this time is, what is it? Y equals x squared plus 6x plus 9. That's relatively nice. So we have this time the negative is with the x. So when we plug in negative 3, we have to include it because it's included in my x point that I'm plugging in. The negative is part of the x value. And that's 6 times negative 3 plus 9. So in this time we are going to square negative 3. We get negative 3 times negative 3, which is positive 9. Minus 18 plus 9. 9 minus 18 is negative 9 plus 9 is 0. So when I plugged in negative 3, I got 0. Negative 3, 0. So that vertex, again, I know it's going to be a U shape. That vertex actually lies on the x-axis. So this would be considered an x-intercept. You don't have to technically plot that in this one, but it's just neat to know that there are x-intercepts and y-intercepts. So speaking of said y-intercept, let's find that y-intercept. Y-intercept we know is my c value. So if I look for my c value is 9. So my y-intercept equals 9, which is the point 0, 9. That is up off of the graph, which is okay. 0, 9. If we're going to reflect it, 1, 2, 3 away from the axis of symmetry. So I would go 3, I would go 3 the other way. 1, 2, 3 takes me right here. And that is negative 6, 9. Good. We have 2 points. Let's pick an x value. I'm not going to pick 1. Because if I pick 1, it's going to be up into this area. And that's going to be off the chart. Remember how I suggested that you pick a point, an x value, close to the vertex. My x value for my vertex is negative 3, so I'm going to pick somewhere in that general area. Negative 4, negative 2, negative 1, whatever. I'd pick from those 3 values. Let's pick negative 1. I didn't do that in the answer key, so let's see what we get. So if I'm going to do my 4th point, I'm going to choose negative 1. My equation, remember, is y equals x squared plus 9x plus 6? Nope, plus 6x plus 9. Plus 6x plus 9. Y equals negative 1 squared plus 6 times negative 1 plus 9. Negative 1 squared is 1. 6 times negative 1 is negative 6 plus 9. 1 minus 6 is negative 5 plus 9. Negative 5 plus 9 is 4. So when I plug in negative 1, I got positive 4. Negative 1, positive 4. Negative 1, positive 4 is here. That looks relatively close to the shape that we're expecting. Negative 1, positive 4. That's 2 away. So I'm going to reflect it over the blue line, which took me to negative 5, 4. I have 5 points now. I'm going to connect those dots, draw the arrows, and we are done. Hopefully that helps. Hopefully you got those same solutions. Now, let's talk about that, same solutions. Well, we're all going to have the same vertex. We're all going to have the same y-intercept. But our 4th point may be different. I chose negative 1. Maybe you chose negative 2. Maybe you chose 1, 2, whatever. So we may differ there. So I'm going to need to see all of your work in a nice, organized, legible fashion. You heard it here. Good luck.